Yeah. Yeah, like these questions, once you get pointed in the right direction, they're not difficult, right? You're just sort of organizing yourself so things are good. Emily, can you take it from there, please? 9 times 7. Thank you. 63 and 23 should be 90. So then you say therefore in the 10th row. There are 9. And again, I'll word this using the Raptors. Depending if the Raptors don't play playoffs by the time the next okay, makes sense? I think it's just like a wording I can understand what you're looking for. That's all that one was. Okay. I'm going to do 15 quickly, then I want to get started on the lesson. 15 says the 50th term and the 9th term. I'm not going to do 15 because it's just like our warm-up. If I skip 15, 15 is exactly the same as our warm-up, right? Except for the numbers will be nicer. That'll be the only difference. Is that cool? Whoever wrote 15? Okay, it's very just like what we did, except for instead of being this, it'll be like 3n plus 5 or something nice like that. Okay? Yes? If you made a complaint, come see me at lunch and we can go through it, but it's almost identical to that. You join the class to start with one rather than left side, I can't help you. It'll be 5 jokes probably in part of these. Here we go. Geometric sequences is today's lesson. And I'm going to also tentatively set the test for next Tuesday then. So, test number, what are we up to? 5? 4? The 28th. And it's going to be choice number 4 will also be. So I'll hand out that choice on probably Thursday or Friday and give you guys the weekend to start. As mentioned on Monday, I'm at a conference at St. Mary's, so all the math teachers are in St. Mary's, like from around all over the place will be here. So I will not be in the class, but I will be sort of in the building, so I'm probably going to peek my head halfway through and I'll say, hey, how's the video going? And stuff like this. So I will be in the building, so if you need help or something, you can still ask. Tuesday will be the only day I'm here next week, so we'll do the test that day. I'll be here at lunchtime if you need extra time and all that stuff. I'm also going to stay Monday night after school, so for those people that are freaking out, you know what I mean, for the test, you can stick around after school and that works as well, unless we strike, but I'm not sure you joke. Here we go. Today's Mr. Warren got me fired up yesterday. Okay. No, I don't even want to get into it. Geometric series. This is used for exponential growth, and that was our whole last unit was exponential growth. An example of an exponential equation okay, I'm not going to pick on Tristan because I want to be kind to start. Okay, can somebody think back to last week and let me know what an exponential equation is? What does it look like? Luke, go ahead.
X to the y.
Yes, I'm going to start simpler than that. That actually wouldn't work in this case because we're dealing with in terms of x. What has to happen for an exponential equation? What do we need? Yeah, go ahead.
G to the x.
Yeah, so I'm going to start small. You're way up here. Let's bring it down a little bit here, okay? I'm going to say maybe 3 to the x, okay? There has to be a variable in the exponent. That's where there has to be. Okay? Excuse me. So how do you get, like, if for a sequence that would be like 3 to the x, what would the sequence be if that was our sequence? What would the numbers be? What would T1 be? 3, good. What's T2 going to be? 9, good. What's T3 going to be? 27. What's the pattern, Tristan, that we're using each time? Yeah, okay. So you're going to be multiplying by 3 each time, okay? So in geometric sequences, you multiply or divide by a common ratio to get the next one. Okay, an example of this, excuse me, is going to be 2, 6, 18, 54, 162, comma, dot, dot, dot. Looking at this sequence, Robin, why is this not going to be arithmetic when you look at that sequence? What does it have to be arithmetic? Yeah, yesterday was arithmetic, so we just add by the same thing each time. That's what we're doing. This one we're multiplying. Take a look. Everything's times it by 3. As what happened yesterday, you have to be multiplying by the same thing each time for this thing to work. Okay, so yesterday's number we have to add by the same thing. In this case, we're going to multiply by the same thing. We're going to get an equation up here right now. So I'm sort of excited here. We almost caught up here. I apologize. I didn't teach first period, so like I said, this is like it's 9:15 for me right now. We're good? Yes? All right, here we go. Here's the equation for a geometric sequence. So the general term of a geometric sequence. Is going to be Tn equals ARN minus 1. Okay, what does that sort of look like? Probably nothing. Okay, yeah, go ahead.
Kind of looks like the y to the x.
Sort of like y to the x, sort of. Okay, I was going to say it might look like the half-life equation. It may look a little bit like pain if you sort of squint. Okay, right? It may look sort of like that. It's the same similar idea. Okay. So looking back to pain, what do you think? Anyone guess what A would stand for? Matt, what do you think A would stand for? A is the starting value. All right, Carissa, what do you think N means? Yeah, the term number of terms. Yeah, term number. I'm going to leave R for a sec for Brad. Cool. What do you think Tn stands for again? General term, okay. Or the value of the nth term. Okay, Brad, what do you think R stands for? Just in English here, we don't worry about that thing. Somebody help me there. One more time? The ratio. Okay. What does the ratio mean in English? What does the ratio mean in English?
When you're multiplying or dividing.
We're multiplying by each time. Okay, so R is going to be my ratio. And that's going to be what you're multiplying by each time. So there's our second equation in this unit. They're going to be at 4 is what there will be. Okay, so we use this one a lot. As you probably at the main class yesterday, you were frightened by Tn equals A plus N minus 1b, and then you did some of the questions last night. It's a piece of cake for now, right? Okay, it'll be the same thing with this one. It looks frightening. Okay, but once you do a few questions, it'll be straightforward. Okay. Now again, this is like the pain formula and all that, right? There's your starting value, there's your ending value, there's what you're multiplying it by, and there's your time. It's a very similar, all those equations are similar to each other. Here we go, example 1. It says, a geometric sequence uh, 3, 6, 12, comma, dot, dot, dot is given. Find T11. Okay. So I'm going to slow down here and give you guys a second to scribble. So I'm getting too excited. So it's cost here. Okay. Be brave, please, and recite from memory or from the page the geometric sequence, please, nice and loud.
Tn is equal to a times r, the exponent n times.
Very good. So Tn is equal to a r n minus 1. Awesome. I'm going to write all this stuff on the left-hand side. Okay. All right, Leah, can I get something else for this question, please? A, R, N, or Tn, please?
A is 3.
A is going to be 3, good. All right, Alana, something else, please?
R is 2 and 11.
Great. That's on there. Okay, now the reason how we got R is 2, we just did 6 divided by 3 is 2, and 12 divided by 6 is 2. Okay, and we're going to assume the pattern keeps going because it goes dot, 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 dot. Okay. Does that make sense where the 2 came from? Because that's the only, it's easy on this one, but as we get to the further examples, we're going to actually have to do some calculations. All right, Marissa, can you step the numbers into the equation for me, please?
3n equals 3 in the bracket.
Yeah.
And 0
Yeah.
to the exponent 11 minus 1.
Okay, now we have to think back very carefully to the last unit. All right, because it's very, very easy to make a mistake here. All right, someone in this class, let's call him, sorry, Tristan, call him Tristan, is going to tell me that's 6 to the 11 minus 1. Why is that wrong? Tristan, go. Sorry? Yeah, bedmass, very good, right? There's lots and lots of 2's. Remember, there's 1, 3 times 10 2's, right? And I'm actually going to write this right now. I'm going to write 3 times 2 to the 10. If I was doing this on my calculator, does anyone need a calculator before we start here? Because this is big in-duty stuff. We're all good? Okay, so what I would do is I do 2 to the power 10 equals and then times that by 3. That's what I would do. If you have a super calculator like Jennifer, you can do it all in one step. Okay, and there's no big deal, but for most people, though, you'd probably have to do it in 2 steps there. All right, Marissa, you're going to give the whole class about 10 seconds to try this themselves, including Brad on his new calculator. It's not new, you got it.
No, I'm ready.
Calculator so fast. It's wonderful. All right, Marissa, what did you get for an answer, please?
1024.
Oh, and then times up by 3, I think. 3,072, I think. It's 3,072. Good for people? All right, so 2 to the 10 first and times up by 3. And I think that should be it.
Yeah.
All right, here we go. Ready? Yep, 2. Find the number of terms in the sequence 9, 27, 81, comma, dot, 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 comma, oh, my mind's gone blank. Oh, here we go. 1, 5, 9, 4, 3, 2, 3. Okay. So I want you guys to try it, thank you. I want you guys to try this for yourselves here right now. Okay. When it says find the number of terms, what am I looking for? N, good, okay. If you're looking for n, what am I going to probably have to use in this question? Probably logarithms. Good, Tristan, okay. You could, this one, because it has to be a whole number, you can use the football method and count on your fingers, that's fine, okay. But logarithms will be a lot faster, and that's how I'm going to do it, okay. So take a second, try it out. If you said, man, I'm glad that last unit's over, so I'll never have to use logarithms again, you're wrong. You will have to use them again, or at least one more time. Actually, twice. Okay, please.